Okay, guys, so this is lesson 6.4, and I'm actually recording this while we are all at home with this stay-at-home order. So I hope that everybody's doing well. I know we wish that we could all be at school right now, but this is what it is. We have to deal with it. So, one thing I want to say is I feel like the biggest challenge that I'm encountering with this learning online is just the lack of communication. And I feel like I put out the announcements and people don't read them, or else maybe they read them and then they don't remember what they have to do. So just, try to get super organized, and every day when you wake up, have a to-do list, what you need to do, what to do that day for all your classes, all on one thing. And then that way you don't miss due dates, because it's so tough when I start getting emails, I missed the deadline, here it is. It's just so much work, and I know everybody's going through a lot, but it's just so much to manage. So if we could just get that part of it down with the deadlines, it would be so much easier for me. And I'm actually open to suggestions that you guys have that I can do to make it easier for you. So anyway, I miss you guys. I hope everything is going great. Email me anytime you need anything. Anything comes up, whatever is the situation, just email me and just know I'm here for you. Okay? All right, so this is lesson 6.4. So we're going to be doing logs for a while. And inside this box, it shows you how to convert from a log to an exponential and an exponential to a log. And it's super important that you know how to do this. It's really the basis of a ton of the problems. So anyway, if you had 2 to the third power, and if someone asked you what is the base of 2 to the third, the answer is the 2. It's whatever raised to the power. So this right here in exponential form, the base is a b. Well, the awesome thing over here is in log form, the base that's an exponential is also the base in log. So the way you read that is log base b of x. So b is the base here, and it's also the base here. So to convert it, here's what you do. You take that b, if I'm going from exponential to log, and you go log base b of the other side, which is an x, is equal to, the only thing I haven't written down yet is a y. And if you go the other way from a log to an exponential, you start with the base, you start with the b, and you raise it to the other side, which is a y, is equal to, the only thing I haven't written down yet is an x. Okay, so let's do this one. So question 1a, always start with the base, so it's 5, and then it's raised to the other side, which is a 2, is equal to, the only thing you haven't written down yet is x. So literally that's your answer. Don't square the 5, which I know is strange, but if you square it, then it's not going to be an exponential form anymore. Okay, so question B, you write down your base, which is a 4. You raise it to the other side, which is a 3, is equal to, the only thing we haven't written down yet is 64. Okay, this one right here, base is a 5, raised to the other side, which is a 2, is equal to, the only thing I haven't written down yet is a 25. Okay, this one right here, base is a 7, raised to the other side, which is a 0, is equal to 1, and those are your answers. By the way, guys, when you scan your homework, I think the highlighting doesn't show, like it messes up, someone told me. So anyway, maybe box your answers from here on out, because I think scanning might be bad. Okay, so now going from exponential to log, this is obviously an exponential because you don't see the word log. So you go log base And what's the base up there? A 6, so you just put it there. To the other side, which is a 1, is equal to 0. That's it, okay? So this one right here, write down the word log. The base up above is a 5, so this base is a 5 of the other side, which is a 25, is equal to, the only thing that you haven't written down yet is a 2, and that's your answer. Now you have to be super careful. If you're one that tends to be like a little bit sloppy, this is going to be a problem, because if you write it like this, log base 5 raised to the 25th is equal to 2, you're not going to get credit for it, because the 25 is supposed to be on the same level as the log, and this 25 is an exponent. And then I'll get people, going like this. And then I'm like, okay, is that, an exponent? Like, what's happening? So just draw level and make sure the 25 is not an exponent, okay? Okay, so this one is log base 4. It's subscript, so it's down below, of the other side, which is a 16, is equal to x. That's it, okay? Next one, write your log. The base here is a 3, so the base here is a 3 of the other side, 1 over 81, is equal to -4. Now, if what I'm taking the log of is a little complicated, I always like to put parentheses around it because I think it looks a little more clear, and it's also going to help me not to get confused. So if I were you, I would put parentheses right there. Okay, this one right here is log base 5. It's a base of the other side, 1 over 125, which is a little complicated, so I'm going to do parentheses, is equal to, the only thing I haven't written is 2x, okay? Okay, so question 3, find the exact value of each log. So these, it's hard because I didn't go through what you learned before, so give me 2 seconds. I just want to scan and make sure you've seen the rules. I'm so sorry, just give me 2 seconds. Okay, so we're right here. So here's what I want you to do. There's a lot of different ways to do these. And so here's how we're going to do these ones. You're going to let it be equal to x. And then I want you to write down stuck. And then I want you to draw an arrow, and I want you to put convert. So when you're stuck, you convert it, okay? So stuck means the log is all alone. So see that log over there? The 2 is part of the log, the 8 is part of the log. That's all one thing. So you're stuck. If it looked like this, log base 2 of 8 plus 1 equals x, you wouldn't be stuck because of the 1. The 1 is not part of the log. So anyway, over here you're stuck, so you convert it. 2 to the x power is equal to 8. And then I want you to write down the word think. So at this point, all you're going to do is just think about it. So 2 to what power gives you 8? That would be 3. So that's your answer, okay? This one right here, set it equal to x, and we're stuck because the log is alone. So it's 5 to the other side, which is an x, equals 1. And then I want you to think about it. 5 to what power gives you 1? Well, it's 5 to the 0 power. That's it. Okay. Next one, set that equal to x. You're stuck, so you convert it. So it's 7 to the x equals 1 over 49. Okay. Now this one's a little bit trickier because of the fraction. But immediately I look at the 7 and the 49 and I'm like, okay, 49 is 7 squared. So I'm trying to get the bases so they're the same. So it would look like that. 7 squared is 49. And then I want to pull that 7 squared up. So if it's on the bottom and it has a positive exponent, then when you pull it up, it becomes a negative exponent. So if 7 to the x power is 7 to the -2, a negative second power, then you know x must be -2. That's it. Okay, this one, set it equal to x, convert it. So 8 to the x is equal to the square root of 8. And I can see I've got my 8, right? So if I could have 8 to this equals 8 to that, then I know my exponents would be the same. So I'm going to leave my x alone. The square root of 8 is the same thing as 8 to the 1/2. So therefore, my exponents must be the same. So x must be 1/2. That's it. Okay, use your calculator. Okay, this is so bad. Oh, good, there's one right there. I was going to say I'm going to have to run downstairs and get my calculator, but I'll use this one. Okay, so grab your calculator and hit log, and then punch in 100, close it off, and hit enter. And we're going to add to the directions to round these to 3 digits past the decimal. So that would be a 2. And the rounding to 3 digits doesn't apply to this because, you know, it ends basically. Okay, so hit ln, which you guys know is log base e. And so hit ln 1.43, close it off, hit enter. We're going 3 digits, so it's 0.358. Okay, next one. If you go ln negative 2.64, close it off, hit enter, you get an error. Well, the reason is you can't take the log of a negative number. And an ln is a log, it's log base e. So this right here is not possible. You can't take the ln of a negative, okay? So this one right here, question D, they're not asking you for the ln of 0.7482. They're asking you the log of what is 0.7482. So basically you're stuck. So if there's no base, it's log base 10. So it's 10 raised to the 0.7482 is equal to, the only thing I haven't written yet is an x, okay? So now everybody go 10 to the, and then go 0.7482, hit enter, and we're going 3 digits. So x is 5.600, okay? The 1 doesn't tell you to round up, so you don't have to write it. And the zeros at the end are silly because it doesn't make any difference. So I would write it like that. If you leave your zeros, it's fine, okay? So ln is log base e, okay? So you really have log base e of x is 1.335. And now you convert it because you're stuck. So you go e to the 1.335 is equal to x. And then you grab your calculator and you go second ln 1.335, hit enter, 3 digits, 3.7999. So that 9 tells you to go up. So the 799 goes to 800. So it's really 800, but we already talked about the fact that those zeros aren't necessary. Put them or don't, it doesn't matter. Okay? Okay, now we're going to graph a log. And then once we graph a log, we're going to graph some adjustments. It's not a race for sure, graphing these, but you can graph a log in literally like, I don't know, 20 seconds, something so fast. So look at the curvature of what that log graph looks like, okay? This right here, you guys, is an asymptote. And that red asymptote hits the x-axis. So it's going to be x equals. You have an x-axis at 0. Sometimes it's confusing, like one, either the log or the exponential has a horizontal asymptote and one has a vertical asymptote. And one of my students one time told me this. They said, well, a log begins with the letter L. And if it begins with the letter L, then the asymptote looks like the letter L. So I thought that was a pretty smart way to remember it. So anyway, here's what I need you to remember about a log graph. A log graph always hits that point right there. If it's a parent log, by the way. So that ordered pair is 1, 0. And then the other point it hits is b, 1. And b, if you look at the equation, it's just whatever your base is, okay? So if you look at this equation, if you go from the origin How far did I go right before I went up 1? That was 2 units. So I'm not being asked to come up with the equation for that, or the equation for that graph, but I could. It would be log base 2 of x, because from the origin I went right 2 and up 1, therefore my b is a 2, and that's where I put it, okay? So that's what you need to remember right there, and you can graph this thing so fast. Then once you have it graphed, then you can start asking what's the domain and the range and all that. So by the way, these are parent. So I want you to write down the word parent. These things work for the parent, but then once we start doing adjustments, it changes things. So if you look at the graph, domain is x, start at the left, move to the right. Where's the first place that it hits it on the left? A 0, but it doesn't touch it because it's an asymptote. So it's 0 and bigger. So that would be 0 with a parenthesis to infinity with a parenthesis. Range is y, start low, move up. It hits everything. So the range is all real numbers, okay? X-intercept, look at the graph. It is 1, 0, and that's it, okay? So if you have like y equals log of 5 and there's no base, that's log base 10. So if there's no base written there, it's base 10. And then if it's an ln, if you have like y equals the ln of 5, ln is just log base e. And again, I'm sorry, I don't know if we have discussed this in a previous lesson because I'm just like randomly teaching this lesson. Just remember that e is 2.718, I think is the exact value. So you guys feel comfortable with pi. You understand what pi is. Well, e is just like pi. Yeah, it's 2.718. It's just this number that doesn't end and it doesn't change, and you know, it's just like a pi. Instead of 3.2, it's 2.7. Okay, or 3.14. Okay, so let's graph this. Okay, so watch how fast I can graph this. First of all, this is a parent graph. How do I know it's a parent graph? Because if it looked, say, like this, that would be shifted down 2. That's not a parent because it has an adjustment. If it looked like this, minus 2, that would be shifting it right 2. That has an adjustment, so it's not a parent. If you had like a 3 out in front, has an adjustment, it's not a parent. Well, this doesn't have any adjustments, so it's a parent. So look what I do. I always start with the asymptote. So looks like an L. It always hits the 0.10. My base is a 2. So from the vertex, go right 2, up 1, curve it in, and that's it. Now, I know that was just the same graph we looked at, but you know, basically that's how you do it. Now, right here, they're asking you for a table. Well, I think a table is silly because I just graphed it in like 20 seconds with no table. And the table is what's supposed to help you do it. But I already did it and I didn't even use the table. So we'll fill in the table, but just know that I think it's silly and unnecessary. And I want you to know how to fill it in if you need to. But, you know, I would never do it unless I had to. So when you do a table with a log, I want you to convert it. So write it as 2 to the y power is equal to x, and then plug in values of y, because it's easier to deal with an exponential than a log. So if y is a 0, 2 to the 0 is a 1. If y is a 1, 2 to the first is 2. If y is a 2, 2 to the second is a 4. If y is a negative 1, then you have x equals 2 to the negative first. Pull that exponent down, pull the whole thing down, pardon me, and the exponent then becomes a positive 1. So that would just be 1/2. So if you look at this, guys, look, 1/2 negative 1, go right 1/2 down 1, it's right there. 1 0 is here, 2 1 is there, 4 2 is there. So I already knew that, and I didn't have to, you know, do all that work. Okay, so I want everybody to write f of x equals log base e of x. And then I want you to write the word parent because it's a parent graph. There's no adjustment. There are no adjustments. So I know my asymptote is here. Watch how quick and easy this is. I know it hits the 0.10. go back to the origin, and I go to the right, whatever that base is, and then up 1. Well, e is 2.7, so I'm right here. So I'm going to go up 2.7, right 2.7, up 1, curve it in, done. That's it. Okay, now let's just jump through these hoops and fill in the table, even though I think it's silly. So there's your equation, and now you convert it. E to the y equals x. If y is a 0, e to the 0 is a 1. If y is a 1, e to the first is an e. What if y is a negative 1? Then you have e to the negative first. Bring it down, it becomes a positive, so that would be 1 over e. Okay? All right, question 6. Okay, here's your graph. You're going to have adjustments, and you have to do all these other things. So this is super important. These things right here, I want you to skip these. And the first thing I want you to do is to graph. And then once you have the graph, I want you to go back up, okay? Up above that, everybody write down y equals a times log base b of x minus c plus d. So what do these things do to the graph? Well, if there's something there, you either go up or down. If it's a positive, you go up. If it's a negative, you go down. If there's something inside the x, like that 1's right there, you're either going to go right or left. And remember the phrase, the x lies. So you actually do the opposite of what you think. So if it's a negative, you go to the right. And if it's a positive, you go to the left. And then the a, if there's something there that's not a 1, it's either a stretch or a shrink. It's going to be a stretch if a is greater than 1, and it's a shrink if a is less than 1. And if it's equal to 1, then it wouldn't be a stretch or a shrink. It would just be normal, okay? All right, so let's come down here and graph this. So the first thing I always want you to do is to graph the parent, okay? So I want you to write down y equals log base 3 of x. And we can graph this very quickly and easily. So I always do my asymptote first. By the way, the asymptote has to be there. If you don't have an asymptote, then you're going to lose points, okay? It hits the point 1, 0. And since my base is a 3, I'm going to go back to the origin. And I'm going to go right 3, up 1, curve it in, and there it is, okay? Now I'm going to list the adjustments. So see that minus 2? It takes my graph and shifts it down 2. The minus 1 takes my graph and shifts it to the right 1. Okay, if I have a vertical asymptote and I shift it down, it doesn't change. But if I shift it right, it does change. So there's my asymptote. I always start with the asymptote, okay? Okay, this point right here is 1, 0. So if I put my pencil right here, then if I go down 2 and right, oh, I went right 2. Oh, I did that wrong. That asymptote should be right 1. Sorry about that. If we were in class, you guys would have raised your hand the second I did it and corrected me, which I love that. Okay, so put your pencil at 1, 0. Go down 2 and right 1. So that's where that point went. Go put your pencil on 3, 1. And then go down 2 and right 1. Curve it in, and that's your graph. So it's really pretty simple. Then look at this graph and go back and answer the questions. Find the domain. Go from the left to the right. It starts at a 1 and it goes on forever, but it doesn't touch the 1. So it's 1 with a parenthesis to infinity. Find all the intercepts. So you guys know I expect you to write x-intercept and y-intercept. So to find the x-intercept, you let y be 0. To find the y-intercept, let x be a 0. Look at the graph. Okay, now this is a little tricky because the y-intercept, like I haven't graphed it yet, right? Pardon me, the x-intercept. Look at the y-intercept. You can tell it's never going to touch it. So you have to list it, and then you have to write none, okay? So there's a couple of ways to do this. I'm going to just let my y be a 0. And I think most of you guys can probably handle this. So if you go log base 3 of x minus 1 minus 2 equals 0, okay? Now, we haven't solved log equations yet. I wonder if that's correct. Sorry, I remember. Oh yeah, there, it's down here. So anyway, here's how you do it, okay? You're not stuck because of that 2. So pull your 2 over and it becomes a positive. So it looks like that. And now you're stuck because the only thing on the left-hand side is just the log. So now you convert it, and when you convert it, it's 3 to the second equals x minus 1. 3 to the second is 9, so x minus 1 equals 9. Move your 1 over, and you get x equals 10. So your x-intercept is 10, 0. And then the asymptote of that final graph hits the x-axis, and it hits it at 1, and that's it. Okay, so let's do this one. So skip A, B, and C and go straight to D. Now, the tricky part, it looks bad. So what we're going to do is we're going to reorder it. So I want you to write y equals negative ln of x minus 1 plus 4. So all I did is write the ln first, kept it negative, pushed the 4 back, kept it a positive, looks a little better. Okay, so the first thing we're going to do is graph the parent. And I could put ln x, totally could do that. Just because I think it's easier for you to understand, I'm going to write it as log base e of x. It's the same thing, it doesn't matter. Okay, so it's a parent. So there's your asymptote. Parents always hit 1, 0. My base is in e, so pencil at the origin, write 2.7, up 1, curves it like that, okay? Now, let's list our adjustments. So the plus 4 shifts your graph up 4. The minus 1 shifts your graph right 1. And remember, a negative is a reflection. So the question is, do you reflect it across the x or do you reflect it across the y? Well, remember, if you alphabetize x and y, the x comes first. So if the negative comes first, it's reflected across the x-axis. If the negative does not come first, if it's within, then it's a reflection across the the y-axis. So right at the beginning of the ln, that's x-axis, okay? So this is reflect across the x-axis. Remember when we had done transformations of graphs before, and if there's ever a reflection, that has to be your next graph, and that's all you can do is just the reflection. So I'm going to fold it across the x-axis. So if I take that asymptote and fold it across the x, the bottom would come up and the up would come down, so it doesn't change it, okay? This point right here, 1, 0, also does not change. This 2.71 becomes 2.7 negative 1, and there's your reflection, okay? And then on the last graph, I'm going to take that and I'm going to go up 4 and then right 1. So taking a vertical asymptote up doesn't change it, but moving it right does. So it's going to go like that. I'm going to put my pencil at 1, 0, and I'm going to go up 4, 1, 2, 3, 4, and right 1. So it's going to be right there. Then I'm going to go 2.7 negative 1, which is here. I'm going to go up 4, 1, 2, 3, 4, and right 1. So it looks like that, okay? Now I'm going to show you a little trick that I do. See this point and this point? I monitor the stretch between those. So this would be up 1, right 1.7. Look at this, 1, 1.7. Did I continue? 1, 1.7. Yes. So my numbers didn't get tweaked. Okay. So I can just do a quick check and make sure I didn't mess up. Okay. So now take that final graph and let's find all these other things. So domain is x, go from the left to the right. So it goes from 1 to infinity and it's not going to touch the 1. Name all the intercepts. So I'm going to go x-intercept and y-intercept. So it's obviously not going to touch the y-intercept, so I'm going to put none. Now to find the x-intercept, I'm going to let y be 0. So everybody go 4 minus ln x minus 1 equals 0. Move my 4 over. So negative ln of x minus 1 equals negative 4. Change my signs. Ln of x minus 1 equals 4. Now remember that ln is the same thing as log base e. You can write it however you want. And now I'm stuck, and remember when you're stuck, you convert it. So it would be e to the 4th is equal to x minus 1. Pull your 1 over, and you have e to the 4th plus 1. Okay, so I'm going to go e to the 4th plus 1, comma 0, and that's it. And then look at that graph. It hits the x-axis. Where does it hit it? At 1. So your asymptote is x equals 1. Okay, that's it. Let's do question 8. Okay, so this is a piecewise function. So first I want to graph y equals log base e of x, which is y equals ln of x. So it's a parent. So there's my asymptote. It hits 1, 0. Pencil at the origin, right? 2.7 up 1, curve it in. You know what some people do, guys? Instead of going from the origin and then write 2.7, they go from that point 2.7 and 1. That is not correct, so be careful. Okay, the only piece of that graph that's supposed to be there are those that have x values of 1 or smaller. So here's 1, smaller is to the left, so all that to the right would go away. Okay, now let's do the next one. So what I'm graphing is y equals negative log base e of x, or negative ln x. So I'm super visual, and I want to see that graph of ln before I reflect it, because otherwise it's kind of tough for my brain. So I'm going to go 1, 0, back to the origin, 2.7 comma 1, and I'm going to curve it in, and now I can like see that graph. Okay, so there's my parent right there. And now the location of that negative is to reflect it across the x-axis. So the asymptote's not going to change. I'm going to graph this in green. The 1, 0 is going to stay 1, 0. The 2.71 is going to be 2.7 comma negative 1. And this down part is going to come up like that. So when I reflect it, it looks like that. Okay, and then the only part of that graph is supposed to stay is where x values are bigger than 1. So here's 1, bigger's to the right, so all this to the left I've got to get rid of. And remember, when an open circle intersects with a closed, then it's closed. Okay, all right, question 9. So this is important. I think it's highlighted that it showed up on a final before. So when you take a log, whatever you're taking the log of cannot be negative, okay? Let me do something really fast. It also cannot be 0. So all you do is take that 4x minus 5, the whole thing that you're taking the log of, and you say that it has to be greater than 0. That's all you have to do. So it's just going to be 4x is greater than 5, divide by 4. So x is greater than 5/4, and that's all you do. Okay, number 10. So what I'm taking the log of, the 3x minus 1, has to be greater than 0. So 3x has to be greater than 1. So x has to be greater than 1/3. Literally, I'm done. Okay. Okay, so number 11 might freak you out. I think I've actually thought about removing it from this lesson, but you know, I've just kept it because I feel like, what if it shows up? You know what I mean? So anyway, it's log base 3. So what I'm taking the log of has to be greater than 0. Well, now it's weird because you've got a fraction. Well, this is a critical numbers type 2, actually. So you have to remember all the steps for critical numbers type 2, which is get a 0 on the right, done. Get a common denominator, done. The next step is to factor. So on the bottom, I'm going to take out an x, and I'm left with x plus 4. The next step is listing your critical numbers. So from the top, it's x equals 1. From the bottom, it's a 0 and it's a -4. All the circles are going to be opened because I don't have an equal sign, so I don't have to worry about restrictions. So -4 is over here, 0 is here, and the 1 is pretty close to the 0. All my circles are going to be opened. And now I have to test a region. Since 0 is a critical number, I cannot test it. So I'm going to test like a 2. So if I go to store, actually, I'm using a graphing calculator because I didn't want to run downstairs. So you guys go to, is it Membar? I think it's store. To store, enter. That's what you guys hit. To store, enter. And then you're going to go parenthesis, Membar, enter, -1, close it off, divided by parenthesis, and we're going to put this in. This is the one I'm going to have you guys put in because it's going to be easier. So you're going to go Membar, enter, x squared, plus 4, Membar, enter, close it, enter, and you get a positive. So I know this region's a positive. Do you see this x minus 1? Exponent's a 1. This is a 1. This is a 1. Since they're all 1s, I know they're going to alternate. So it's going to be minus, plus, minus, plus. I'm looking for greater than 0, which is positive. So it's there and there. So if I write my answer in interval form, it's -4 to 0, both with parentheses. Union 1 to infinity. Looks like that. Okay? All right. Now, I'm trying to see how much more we have. We're going to solve these logs, okay? I want you to remember that when we get stuck, you convert. You have to know the difference between stuck and not stuck, okay? If you have log base 4 of x equals y, that's stuck. It's stuck because everything on the left is part of the log. If you had a 3 right there, not stuck. You would divide by 3. If you had a negative there, not stuck. You would have to change the signs. If it looked like this, not stuck because of the 1. If it looked like this, not stuck because of the 1. The negative 1 is not part of that log. Okay, so look right here. We're stuck because everything on the left side is embedded in that log. It's part of the log. So when you're stuck, you convert it. Okay, write it over here pretty far to the left. So when you convert it, it's 3 to the other side, which is a 2, is equal to 4x minus 7. 3 to the second is a 9. So you have 9 equals 4x minus 7. Move your 4 over, or pardon me, your 7 over, it becomes a positive. So you have 4x equals 16. Divide by 4, and you get x equals 4. Now, here's the tricky part. When you're solving a log, you actually have to check your answer. So what I want you to do is I want you to write the word check. Here's where people mess up, right here. It's a common place where people mess up, but it's so easy, like you don't have to mess up. Look, you just write down that exact equation, exactly how you see it. Not this equation, not that equation, not that, not that. You write down that, except for wherever you see an x, you put in a 4. So go log base 3, and then I turn the parenthesis into a bracket because it's starting to get confusing with a parenthesis and a parenthesis. So then I go 4, parenthesis, 4, close it off, minus 7, close it off, equals 2, okay? So change of base formula. I want to make sure, I'm sorry, I'm kind of all over the place here. So if you were trying to put in log base 4 of 3 into your calculator, you would put that in as log of 3 divided by log of 4. So that's how you have to put it in here, okay? So everybody go log. You know what, you guys, I'm going to like run down my stairs for 2 seconds because I'm going to get your calculator. So give me 2 seconds. feel like you're getting stir crazy. Okay, sorry about that, guys. So, everybody go log. And then you can put in 4 times 4. I'm just going to put 16. So go 16 minus 7, close it. Then go divide log 3, close it, enter, and I got 2. Hopefully you got 2. So you got 2 equals 2. If you get the same thing, totally checks out. Answer's done. Okay? Question B. You're stuck, so you convert it. So you go x to the second is equal to 64. Then you square root both sides. When you square root, you have to do the plus or minus. So it's plus or minus the square root of 64, which is 8. So you actually have 2 answers, and you have to check both of them. So let's check 8. Write down the original problem, and right where you see an x, put in your 8. So the right-hand side is done. Put the left in your calculator. So go log 64, close it off, divided by log 8, close it off, hit enter. You get 2 equals 2, totally checks out. How about x equals negative 8? Well, then you're going to have log base negative 8 of 64 is equal to 2. Well, your base can't be negative, so that's not going to work. So you write the words invalid solution, and the only answer is x equals 8, and you're done. And you know you're right because you plugged it in and it worked, okay? Okay, question C. The nice thing about question C is it's not a log, it's an exponential, so you actually don't have to check it, okay? I'm stuck because everything is within that E. It's part of the E. So I convert it. So I'm going to go log base E of the other side, which is 13, is equal to negative 2x plus 1. Log base E is the same thing as ln. So you really have ln 13 equals negative 2x plus 1. You can write it as log base E or ln, it doesn't matter. Now pull your 1 over. I'm going to reverse the sides as well. So I'm going to have negative 2x equals ln of 13 minus 1. Now I want to freeze right there and say something. I would never write it like that, because my fear is the next thing you're going to do is write ln 12. The 13 is part of the ln, but the 1 is not part of the ln. That's like adding y plus z together. They're not like terms, so you can't do that. So instead of doing that, instead of writing it as 13 minus 1, I would write it as negative 1 minus ln, negative 1 plus ln 13. So let me do something really fast. I feel like I took too many steps at once. So see that right there? First thing I'm going to do, so simple, I'm switching the sides. Okay, that's easy. Now to get the x alone, I'm going to pull the 1 over. So I have negative 2x equals negative 1 plus ln 13. Now to solve for x, I divide by a negative 2, and that's my answer right there. Okay, that's all I do. I don't have to check it because it wasn't a log, so we're totally good. Okay, question D. I'm stuck. When you're stuck, you convert it. So it's y to the other side, which is negative 3, equals 1 over 27. So this is a little tricky. You have a negative exponent, and so I don't want a negative exponent. So I'm going to take that y to the negative third. I'm going to pull it down, and now it's a y to the positive third. And then I'm kind of thinking about this, and I'm like, okay, what to the third gives me 27, right? Well, that's 3. So I'm going to rewrite 27 as 3 to the third. Well, then look, everything matches up. The 1s match up, the 3s match up, and so these things must be the same. So now I know that y must be 3. Remember, it was given in log form, so you have to check it. So you're going to go log base 3 of 1 over 27 equals negative 3. Keep the equals negative 3 on the right, and let's put the left in your calculator. Make sure when I do this, you guys, like you're doing it in the calculator yourself, because it gets a little confusing. So everybody hit log, then go 1 divide 27, close it off, divided by log 3, close it off, hit enter. I got negative 3 equals negative 3, so it totally checks out. So when the check is going to fail is if you did something wrong in solving it and you end up with like 5 equals 2, which is obviously false, or when you put that value in, if you get an error, then you're taking the log of a negative number, and then that's not a solution either. Okay, so question E, you're stuck, so you convert it. So it's 9 to the negative 1/2 is equal to y. I'm just going to switch those around like that. Okay, I have a negative exponent, so I'm going to take that negative exponent and pull it down, and now it's a positive. 9 to the 1/2 is the same thing as the square root of 9, and the square root of 9 is 3. So I got 1/3. Now you have to write the word check. You guys, what people do is they'll plug it in here, or they plug it in here, or they plug it in here. And you don't do any of those. It has to be the first step. So that would be log base 9 of 1/3 equals negative 1/2. So keep the right side alone, and let's put that in our calculator. So grab your calculator and go log 1 divided by 3, close it, divided by log 9, close it, hit enter, and I got a negative 1/2 equals a negative 1/2, so it totally checks out and I'm good. Okay, question F, this is log base 10, so I'm going to convert it, so it's 10 to the first equals x minus 1 over x. 10 to the first is 10, so I'm just going to leave it, get rid of the exponent. I'm going to put a 1 underneath, and then I'm going to cross multiply. So 10 times x is 10x. 1 times x minus 1 is x minus 1. Pull the x over, it becomes a negative. So I have 9x equals negative 1. Divide, x equals negative 1/9. And then I'm going to write the word check. And I have to check from the beginning problem. And I go the log of negative 1/9 minus 1 divided by negative 1/9 equals 1. Do you see how what I'm taking the log of is like so crazy? So that's why I put parentheses like that. Okay, putting this in the calculator is tricky, okay? The base is a 10. So I'm not having to do like this where I went log of 1/3, close it, divided by log 9. I don't have to do that because that's base 10. But putting this stuff in the calculator is tricky. So do you see on the top how you have two terms? You have to input parentheses, and the bottom is a fraction, so you also have to input parentheses. Okay, so here's how you do it. Do it with me. Go log, parenthesis, negative 1 divide 9 minus 1, close parenthesis, divided by parenthesis, negative 1 divide 9, close parenthesis, hit enter. I got 1 equals 1, totally checks out. Okay? All right, question 13 and 14, and then we're done. Okay? So this is an easy question. Chemists use the pH scale to test acidity. Here's the equation. Seawater has a pH of 8.5. Find its hydrogen ion concentration. So hydrogen ion is just your H+, okay? So the pH is 8.5. So right there, I'm just going to put 8.5. So it's 8.5 equals negative log of H+. Don't let the plus freak you out. Just like think of it as an X. It's just part of the variable. So I'm not stuck right here because of that negative. So I have to change both the signs. And now I'm stuck. And since I'm stuck, I'm going to convert it. So that's log base 10. So it's 10 to the other side, which is negative 8.5, is equal to h plus. Okay, I'm going to check something really fast. So if you put 10 to the negative 8.5 in your calculator, you get this like teeny tiny number, like with a ton of zeros, 0.000, like a ton of them. So I'm just going to leave it be. We'll say that's it. Okay. Okay, question 14. The normal healing of wounds can be modeled by this equation, where a sub 0 represents the original size of the wound, and A is the area of the wound after a certain amount of time, so after n days. Suppose the wound had an original area of 100 square millimeters. Well, A sub 0 is your original area. So we're going to write A sub n equals 100 E to the negative 0.35 n. So there's your equation, okay? After how many days will the wound be half of its original size? Well, the n is the days, and the A sub n is the area. So half of the original size after how many days? Well, if they're asking how many days, I know that my n is going to stay an n. So if I start with 100, half of the original size would be 50, okay? And I'm not stuck because of the 100. So I have to divide both sides by 100. And when I do that, I get E to the negative 0.35 n is 50 divided by 100, which is 0.5. And now I'm stuck, so I convert it. So it's going to be log base E of 0.5 is negative 0.35 n. You guys know log base E is ln, so you can write it as log base E or ln, it doesn't matter. To get the n alone, divide by negative 0.35. So it's going to be n equals ln 0.5 divided by negative 0.35. Okay, then grab your calculator and go ln 0.5, close it off, divided by negative 0.35, hit enter, and we're going to round this. We're going to say to 2 digits. We'll say that was in the directions. So it is 1.98 would be the answer. And how many days? So that would be days. Okay, question B. How long before it's 10%? Well, you guys, again, they're asking how long. So I know my n is going to stay in n. 10% of what it was to begin with, well, 10% of 100 is 10. I cannot convert right now because I'm not stuck. The reason I'm not stuck is because of that 100. It's not part of the base or the exponent. So I divide both sides by 100, and I get E to the negative 0.35 n is equal to 10 divided by 100 is 0.1. And now I'm stuck. So now I convert it. So it's log base E of 0.1. Well, log base E is ln, so you can go straight to ln, is equal to negative 0.35 n. To solve for n, you divide. So it's n equals ln 0.1 divided by negative 0.35. Okay, grab your calculator and go ln 0.1, close it off, divided by negative 0.35, hit enter, and we're going to go 2 digits on this as well, and it would be 6.58, and that would be days. Hey, I want to show you something really cool. So see that number you have on your calculator that we just rounded? Store that in for X, so go store, enter, and you can totally check your answer. Put it right there for N, and you should get a 10. So go 100, second, ln, negative 0.35, membar, enter, close it, enter, and you totally got a 10. So I just checked my answer, okay? Okay, that's it, you guys. So strange that I can't see your guys' beautiful faces and that we're dealing with this, but you guys are strong and you're wonderful and you are resilient. So I know you're going to be fine. Please, please, please email me if you need anything, and just know I'm here for you, okay? Email me, talk to me, let me know what's going on, and this will be over before we know it, okay? You guys are awesome. Have a great day.